Hello students, welcome back to Math 245. This week we have been talking all about sets and today we are going to continue that. So today we are going to learn how to illustrate sets using Venn diagrams and we will talk a little bit more about this in lesson 20. So surely we are all familiar with what Venn diagrams are, but they are just a way to visualize sets in which a rectangle represents the universal set. Remember, the universal set is all elements that we are interested in, and circles inside the rectangle symbolize these sets. So in these three examples right here, all of the rectangles that our circles are in represent our universal set. Two sets A and B are said to be disjoint if A and B have no elements in common. In a Venn diagram, this means that the circles would not overlap. So this is an example of a disjoint set. A and B are totally separate circles. They do not overlap at all. The complement of A consists of all elements in the universal set U, or the rectangle that is surrounding our set A, that is not in A. And the notation is this A uppercase C. So in our complement example, the orange shaded portion is the complement of A. It's everything in our rectangle that is not A. That's the complement. And when two circles or sets in a Venn diagram overlap with each other, we call them overlapping sets. So if they have anything that is in common between the two sets, they have this overlap. And the intersection in the diagram indicates the elements common to both of these sets. So these visualizations right here, these examples are a pretty good way to understand what these different definitions mean. So again, disjoint means no elements in common. Complement means everything in the universal set that's not in our set. And overlapping simply means that they have some elements in common. So let's do our first example here. The following Venn diagram shows sets x, y, and z. Which of the following statements is true? Select all that apply. So the first one says x and y are disjoint sets. Well, if I look at x here and y, I can see that x and y do not have any elements in common. That's what it means to be disjoint, so yes, this is correct. What about x and z? Are these disjoint sets? Well, here is x, here is z. Those two sets do not have anything in common. They are disjoint, so that is true. Y and Z are disjoint sets. Well, we can see that there is an overlap here between Y and Z, so C is not true. Y and Z are overlapping sets. Well, yes, if they're not disjoint, then they're overlapping, so that is true. And X and Y are overlapping sets. Well, nope, X and Y don't have anything in common, so they do not have an overlap. That is not true. So if two sets aren't disjoint, if they are disjoint, they cannot be overlapping. And if two sets are overlapping, they cannot be disjoint. So sets are either disjoint or overlapping. They have to be one or the other. It's impossible for them to be disjoint and overlapping or neither one. They have to be either disjoint or overlapping. All right, let's look at our next example. Shade the complement of B and C on the Venn diagram to the right. So I have B here, and I have C here. B and C are overlapping sets. They have this little thing in common right here. So I want to shade the complement of B and C. So in order to do that, I'm going to shade everything in my universal set that is not in B and that is not in C. So I am going to shade this in red. So that is going to be all of this. Shading all of this right here. So the red portion is the complement of B and C. It's everything in our universal set that is not in B or C. So let's write that down. The red portion is the complement of B and C. It's everything that's not B and C. All right, let's use the same diagram to shade the complement of A. So if I look at A, this guy right here, the complement is everything in the universal set that is not A. So if I wanted to shade this in red again, it would be our universal set, except for our circle A. So it would be all of this, all of these other elements besides A. Whoops, I'm having troubles with my pen here. There we go. So let's say the red portion is the complement of A. Everything that's not in A. So that's what it means for a set to have a complement. It is just everything that is not in our set, that is in our universal set. Finally, we have some examples here given in our roster notation. So we want to consider the following sets and determine which of the statements are true. Select all that apply. So I have A, G, and E here. So if I were to draw A, we'll call this A, we'll call this G, and we will call this E. So let's see where I overlap. So A has the elements 2, 4, 6, 8, and I see that G is 1, 3, 5, and 7. So A and G do not have any overlap. So actually A and G should be disjoint. Let's just draw it from scratch actually. So A and G are disjoint. They don't share any commonalities. Here's A, here's G. We have 1, 3, whoops, oh. In A we have 2, 4, 6, and 8. And in G I have 1, 3, 5, and 7. And E is 4, 8, and 16. So E shares elements with A. So if I were to pick out the elements in A that E has, I would have this. And if this is E, E also contains the element 16, which is not an A. So we'll pretend that this oval is actually a circle. So we can see that A and E overlap, but A and G don't overlap. Neither do G and E. So we can see that yes, A and E are overlapping sets. A and G are not overlapping sets, they're disjoint. G and E are disjoint, and A and G are also disjoint. That is true. So again, in this A right here, A and E are overlapping because they share the elements 4 and 8. A and G aren't overlapping since they don't share any elements. G and E are disjoint since they don't share any elements. And A and G are disjoint since they don't share any elements. So yeah, this is a quick overview of what it means for sets to be overlapping or disjoint, as well as their complements. So we are done here. Go on and go watch lesson number 20.